You wouldn't, would you? You'd say, no thanks, I'll take bundle D if I had a choice of those 3 bundles, because it has the most hugs and I'm a hugomaniac and I don't care very much for candy at all. I'd give up a lot of candy to get one more hug. Yeah? So everyone could have, and there could be a candy maniac out there too. There probably are. And so people who really love candy would not be indifferent. They would say, wait a minute, I'm not indifferent among these 3. I would much rather have bundle C than bundles A or B, because I have a big preference for candy relative to hugs. Yeah? So every person has their own preferences. These are just the preferences of one hypothetical individual, and since he can't defend himself, we'll call him Max. Yeah? Here's another set of 3 bundles that also have this property, that those 3 bundles in red, D and F, give the same utility. 3 and 3, 4 and 2, and 2 and 5 all make Max just as happy. You can quickly tell me, would you rather have A or would you rather have D? Remember, more is better. It's all you need to know. Everyone thinks hugs are good and Reese's are good. So if I put those 2 bundles on the table, A and D, what would people choose? A, because it has more of both, right? That's more better at work. And we can tell a little more then. Since we rigged it so A, B, and C are all the same, and A is better than D, is B better than D? Yeah, for this person, it is. Because A, indifferent to B, A, well, I'll do it the other way. B indifferent to A better than D, transitivity, B better than D. Right? That's how the game works. Now we have a third set, and apparently this is the good set. This is what you really want. Can you tell that? Compare G to A. Does G have more of everything? So every consumer prefers G to A. This particular consumer finds H and I to give just the same level of happiness as G. But that's this particular consumer. Maybe that none of you have these preferences. This is only the hypothetical Max's preferences. So now we know something about all consumers. All consumers like this, G, better than A, and they like A better than D, because we can pull that out of more is better. And we know things about this individual consumer because Max told us. It's right here in front of our face. He says these 3 bundles are the same, those 3 bundles, same utility, same happiness. We use the word utility for happiness. I love the fact that we have our own fancy word, but that's what we do. Right? Anywhere it says happiness, if you catch me lapsing into utility, that's just our 19th century word for it. And here we go. Now, we can put this stuff on a graph. And here we have the 9 points on a graph. So if you copy these things off, how many people copy them off before you come? Nobody? 1? Hey, a little aside. As a student, I had to have been the most lazy student there ever was. And if I had had the opportunity to copy the slides and reduce them, maybe 4 slides to a sheet, get them on the front and the back, and take my notes directly on them, geez, it suits my laziness to a T. I would definitely have done it. If you went back, you would find these 9 points are exactly the 9 points from before. And the colors correspond. Do they? Let's see if colors correspond. You get them right? So let's look at thing C. No, these colors do not correspond. Which is the best bundle on this thing? Best bundles. The black, right? And 6, 7, we should be able to pick off on our graph. So here's 6 and 7. There's 6, 7 right there, right? So that's actually the black. How Max gets colors right. So that's the best, 3. And then the middle 3, whoops, the medium 3, right, is A, 5, 5. Let's go find that. Here's 5, 5, right? So that's the medium ones, and the last one's the low ones, yeah? And I graphed just the points, and then I've drawn a curved line through them. And there are some rules for these curved lines. And we can derive those rules from the things we said about preferences. Bundles from the table on the graph and different bundles on the same curve. Okay, so we have these indifference curves. So let's see what we can learn about the indifference curves from our reasonable assumptions. Yeah, they're called indifference curves. So you wanted to circle something. Right? That's a definition. How do you do well in an economics class? Sadly, the easiest thing you can do is you can write down the definitions. So you could go back today and you could write down, what do you want to write down? Indifference curve for sure. Set of bundles that make me equally happy. Yeah, plain English. Go for the plain English. Write down a definition for yourself of indifference curve. It's a set of bundles. Each bundle makes me as happy as any of the other bundles on the indifference curve. Whatever works for you in plain English. That would be best. That's your definition. I guess you want some definition of prefer, but it's so obvious you wouldn't miss that, right? I prefer A to B, right? Like better. So maybe you don't have to write that down. How about a bundle? You want to write that down? Bundle is a collection of goods, shopping basket full of stuff, something like that. That's everything up till now. That's what I would do. And if I were taking something that's hard, like Chem 1A, where I have a pile of cards to memorize like this, I bet you 40 cards would take up this entire course and no more. And you just put them in with the other cards. You'd never even notice them. They're so few. So we have indifference curves. Which are better? Further from the origin. Why? Suppose I wanted to show that B is better than C. C is better than B. What would I do? I would go draw like this. Okay? And so everything going this way between those 2 axes has more of at least one good. So does C, indifference curve C, fall in there? Yes, it does. So C is better than B. Why? More is better. And since all of the points on B are the same, right? All these points are the same, then all the points on C are better than all the points on B. So easy enough to show the first thing. Further away from the origin you are, the better off you are. There's an indifference curve through each possible bundle. I think that's it's easy to draw, right? Pick a bundle, right? Draw an indifference curve. That's easy enough. Does that have to be? Can you begin to construct a proof that has to be? I think it's a hard proof. Let me sketch for you what it has to look like. I've got this bundle, right? I know this stuff out here. That's all better, right? By the same argument, I know all this stuff here is worse. And so if you think of starting here and winding your way around like that, and you're starting off at better and you're ending off at worse, and you're willing to make an argument about continuity, then somewhere in between you have to hit indifferent. And so now you know one more thing. Not only is there an indifferent, another point in here that's indifferent, here it is, but you know where it has to lie. It can't lie up in here because those are all better points. It can't lie down here because they're all worse. They have less of everything, right? So they're worse. So it's got to lie in between the two, and that means the indifference curve has to slope down. There's no way to draw an indifference curve that slopes up. You can test that for yourself over here. Draw an upward sloping indifference curve. Can it be? No. Why not? Well, everything up here is better, right? How can something be indifferent and better at the same time? So you can get a fair bit about the indifference curves. So there's a curve through each possible bundle. That really requires a little math. You have to make some assumptions about continuity to make that go. And what kind of curves do these roll out? Ones that go up. Can't go up. More is better. If it went up and you were indifferent, you would also like it better. You can't like it better and be indifferent at the same time. You can't contradict yourself. You can't go up. Bad indifference curves. Naughty indifference curves. What can indifference curves do? We can use the same three things to find out. So let's draw a pair of naughty indifference curves. Okay, the cross. Yeah? Let's call that point A. Let's call this point B. And let's call this point C. What can you tell me about the relation between C and B, and why? C is preferred to B by everyone because more is better. Now you can construct the rest of this. We know C is preferred to B, but C is indifferent to A because they're on the same indifference curve, right? And A is indifferent to B because they're on the same indifference curve, and therefore C is indifferent to B and C is better than B. At the same time, you have a contradiction, you're done. Right? That's the way these proofs work. So now you know they can't cross. What are the other things they can't do? I never thought they could be thick. Let me draw them trying to be thick. So I think you mean, suppose an indifference curve really looked like that. All right? It's a big fat thing. Now you could look at 2 points on this indifference curve. Choose 1 point on this edge down here and 1 point on this edge up here. So they're one above another. Right? The stick can do that. So is E preferred to D by more is better? If I drew it right, it is it not? So anytime you draw it thick, you can just find something at the top of the thickness and right under at the bottom of the thickness, and you can say, wait a minute, the thing at the top of the thickness has to be better than the bottom, and they can't be indifferent, and one be better than the other at the same time. So they can't be thick. So they're microscopically thin. You can't have 2 points on the same indifference curve, one over another, which is what thick would imply. You can't have them thick. I never saw anyone try to draw them thick, actually. And we already proved they can't be upward sloping. If you want to try something interesting, try drawing. Let's see if we have another pad. Okay, we do. We already did thick. Here, we'll do thick again, just so that we create a decent record. Right, A and then B right below it. Let's see the third one. Upward sloping. We know why that can't be true. We'll just fill it in. Here's an indifference curve that slopes up a bit, and here's my more is better box, and so things up here are better and indifferent at the same time, and it can't be. But now there's an exercise you should do. Take yourself a piece of paper and try to draw a set of indifference curves, one over the other. Try to get about 4 or 5 of them on the same piece of paper without violating any of the rules. Go ahead, do it fast. Most instructive is if you take a little bit of paper and do it fast. No, you need more paper than what you're trying to do. You need to be, because when you go to do a test, you're going to have to draw these. And what are you going to do? You're going to draw me a set of indifference curves and a set of these things and show me this, that, and the other. So you might as well get comfortable with them. So go ahead and take a second and try to draw them. Not a hard thing, you think, right? Yeah, throw in a couple in between you. You're there. Yeah. Now, let me show you what happens when you do it fast, and you can tell me if you did it fast and it happened to you. When you go to do it fast, you'll discover there's a vast tendency to slope up at the end. So look at your indifference curves and see if anyone did that, which is totally wrong. Anyone do it? No? You all drew them so they were all downward sloping? Really? Well, that will be very good because there are sharp-eyed TAs. Is that true? We have sharp-eyed TAs? Yes. They give me thumbs up. And sharp-eyed TAs will take your otherwise beautiful drawing in which you got everything right and find where you sloppily did this. And they will say, bad, don't do, minus points. And in good years, Max will pay you if he makes the mistake at the board. So do ask Max whether this is a good year, and he will pay if he ever draws this. He pays a lot, by the way. So when you go to draw them quickly, you've got to train yourself to draw them downward sloping. It's not natural. I watch people up here, and they're all pretty good. They're much better than I would have been. I would have done this without thinking about it. And that is wrong. Don't do it. Let me write wrong on it just so no one at home. Okay? You don't want to do that. You want them downward sloping like they're supposed to be. And I think Max gave us 18 slides, so I think we're going to be done a little early. Let's talk about what we did a little bit. You're horrified that we're done? I'm used to going through like 30 slides. Max is the better teacher. He slows down more. First of all, are there any questions? We have plenty of time to take the questions. Is this clear as day? Okay, so there's a couple of ways of showing that. This way here, I drew one that's upward sloping. Yeah? I pick a point on the indifference curve. I draw this box. Is this drawn well enough for you? You'll imagine that goes through the point. Yes? Okay. I drew this box, and everything in this box is better than this point because it has more of at least one good and not less of the other. So if I drew this upward sloping, curves up here would be indifferent because they're on the same indifference curve, and they're better because they have more. So upward sloping means, if you compare 2 points on an upward sloping segment, that the point that's higher up has more of at least one of the goods and probably both the way you're going to draw it, and therefore is better. They can't be better and indifferent at the same time. That's a simple argument. Anything else? Yeah, preferred. So we have funny symbols. Let's go back and see if we have all of our funny symbols. Yeah, we'll write down preferred. We'll try to write down preferred. Right, and it can go the other way. And then the last one is indifferent. Here, that's indifferent. Yeah. Okay, those are our funny symbols. Anything else? That's correct. So an indifference curve is the set of bundles that you like equally well to each other. Or the indifference curve through bundle A is the set of other bundles that you like just as well as A. And maybe that's my personal definition. I would go for the indifference curve through bundle A is the set of bundles that you like just as well as A. Okay, that would be my quick definition. And it's easier by starting off from bundle A. Yeah, right. The indifference curve, yes, right. So you got that diagram. You would say bundles A, B, and C are all on the same indifference curve. That's correct usage. Anything else? Yes, sir. Loud, though. Why what? Oh, sorry, which one? Thick curve. Okay, let me do it on the board where I can make something really thick. Okay, I can make something thick. You agree that's thick? In order for it to be thick, there's a point at the bottom of the thickness and a point at the top of the thickness. Yeah? More is better? So this guy has to be better than that guy. And that's a consequence of being thick. In order to be thick, you have to draw an upward sloping line through it. And so more is better rules out thick. More questions? Let's go back. I want to go back for 2 more minutes to preferences. I really like to push on it. I did this class for the first year students. We spent like 30, 40 minutes just discussing what are places where preferences are ridiculous. So let me push you on it a bit. I have a very politically incorrect photograph I haven't brought for you today of an extremely large human. And she's sitting in, I think it's a she, I can't tell. But the human is sitting in a chair. And you can see the human is really, really large. I mean, 300 plus pounds. How do you want to describe this? Do you want to describe this as choice or not? Do you want to say, she did whatever, and that's why she weighs 300 pounds. She made a choice, meaningful choice, and then go the next step. Remember, the next step is, oh, well, if it's a choice, and she made a choice, who am I to interfere? It must be what she likes. How many want to go that way? Okay? An economist, wearing an economist, I have my economist hat on, I would say that's what happened here. It's a choice. Any of you take courses in nutrition or anything like that? No? Any of you read all the articles on food and weight and all that stuff? Yes? Are you ready to describe this as this is just a free choice, like deciding which 2 bundles of candy? Somebody going to take this on? Yeah, with my economist hat on, that's exactly what I'm going to say. And it was a free choice. And, some people just like the food and are willing to take the consequences of their knees fall apart and stuff and get diabetes and die. Not a problem. Is that okay with you? I know you have to be really loud. Well, let's assume they can. Okay? Because otherwise it's in some way not interesting, right? It's not a choice problem if potato chips are cheap and everything else is expensive and the only way to stay alive is eat potato chips and there's something about them where you have to eat enough and blah, 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 blah. It's not an interesting choice question. It might be a very interesting policy question, but it's not really a choice question. Yeah. Well, you see you have 2 ways to go. You go the way she articulated perfectly, then it's a choice. And the consequence of that is, the first order consequence of that is you think, okay, it was a choice. Well, why am I getting involved here? Right? You could go the other way. You pointed out, starving yourself to death. Many of us would not say that's meaningfully in the realm of choice. That's in the realm of disease. We have doctors and things. We try to fix stuff like that. Yeah. We have a heroin addict, and we try to save him anyway, even if it's a choice. We just don't like other people doing that. So how do you get out of the box? It's just a choice. So now it's not magical. The person's not magical anymore. Okay, so that will always work. So let's just I'll go for you and then we'll go back. Okay. So I can make your argument go away by adding in Porsches, right? So all I have to do is add enough other things so that you could have chosen the fast car, the fast bicycle, rather than a bigger pile of food. I can make that go away. Yeah, and then, yeah. Okay, so what you want